Hi everybody, thank you for joining this session. Obviously today is the JPro Dante 101 session, and I'm really excited about this and at the same time extremely nervous, so you'll pick it up in my voice. And I'm really excited to be delivering to this to you guys. So what I really wanted to let you know up front right now is that we did call this Dante 101, but it is going to be, to a degree, Dante basics, not very low basics, just a very good overview of that stuff. But then on the other side, it's going to cover a lot of advanced things that you don't typically get out of the Dante level 1 and level 2 training. So for those of you that are more experienced with Dante, stick through towards the end if you can, or watch the video at another time. But there is going to be quite a bit of useful information at that side of the spectrum. What we are predominantly going to be looking at is these more harder things to deal with in Dante and things. So please enjoy. And one of the other things I should probably let you know at this point is that I don't have a ton of Dante equipment at my house. So most of the stuff is going to be, or most of it is actually PowerPoint driven. But I did custom make the entire thing, so I haven't downloaded this from some website. This has taken me quite a while to build up. So I really do hope you guys are going to enjoy it. During the time, please ask questions. Nicholas is manning the helpline as it is, and he will respond to anything that he can answer. But any of the really big questions and things like that you want to ask towards the end, post them as we go, and I'll get to them right at the end of the Q&A section. So please do enjoy this course. So starting off, this is what we're looking at today: is introduction to Dante, the platform, the hardware, the software, then Dante controller, obviously Dante controller because it's a large part about Dante, and then network configurations, not covering how to set up a switch specifically because we did cover that last week in the Cisco side, but covering which switch technologies you need to look at what point, which I think is a bit more useful than how to set up a Cisco switch for the next 30 minutes when we just done it a week ago. And then right at the end, as I said, there'll be a Q&A. The one thing I also just want to make you all aware of is that of recent, I became a Dante certified trainer, and we were going to do Dante level 1 and level 2 training in New Zealand, in-class training. And that would involve the actual switches and the gear and the setting it up and doing the system in front of them. So as much as you can do Dante level 1 and level 2 online, we are bringing it home in the way that you'll actually get hands-on with our level 1 and level 2 training. And it is the same certification course at the end, but I guess in many ways you'll leave with a bit more experience rather than just a quick Q&A question at the end of it. So I do hope that we're going to be able to bring those to you guys quite soon, because I'm looking forward to those courses specifically. So diving into what we're going to do today. So looking at the platform, the hardware and the software. So the platform, we're going to cover what is Dante. So this is just so we have a very brief understanding, because some people will be a little bit new, but also just to clear up the air around it. So when you're looking at Dante, it's essentially a means of networked audio. It takes audio, be it analog or digital, and puts it onto a platform that is digital audio, networked audio, and it transports it over a network switch, and then you can obviously ramp it off at some point to speakers. This is the basics of what Dante really is a networked audio platform. So there are other types that you get: CobraNet, AS67, QLAN. There's quite a few other ones, but this is essentially a network audio protocol. So what we're going to look at next is how does this change the world or the things that we have. So in front of us now, we have a typical analog style boardroom, probably what you would see 10 years ago, or in some cases you still do find these. And what we have is analog cables running to the DSPs. And this is not necessary to say this is wrong, it's just a version of this. Now, what Dante has done, or any other network audio platform, is move all the conversion that used to happen here at the DSPs to the I/O. So where you might have the microphones or Dante microphones, they'll be transporting and converting the audio at the microphone and then digitally transferring it over a very cost-effective means to the DSPs. Same for microphones and things like that. So this is just looking at what we want to focus on is the analog wiring that's involved in these installs, the distances, the risk of noise, interference, and then other aspects of what we get limited by when we're running with analog cabling to devices. Now, moving to what we currently see, quite a common trend now is you will run cat cable from a switch to a Dante device. And that cable obviously has its limitations, being 80 to 100 meters, 100 meters being really pushing it. But we have now distant advantages. We have means that we can transport audio over quite a long distance. We can distribute things. And also the D to A conversion or A to D conversion is happening at the hardware point. Really a useful thing when it becomes to really large scale deployments, because this simplifies the installation process. It actually reduces time sometimes because it is a lot easier to either hop onto someone else's network infrastructure or simply just be able to install cat cables instead of costly audio cable that's high quality. The other thing we also have then is DSPs and those sort of things will digitally receive the audio of the network, so a single port rather than a lot of preamps and I/O. So we also start seeing now that DSPs are changing the way they used to look and the sizes that we used to get, and limitations are being lifted. You'll see a little bit later on in the hardware how this limitation is getting lifted quite a lot. But what we already see is moving between these two is how all this analog I/O gets eliminated and moved to a digital platform simply using switches. Now, on a more complex form of this, and this is what we see more recent in larger deployments, is a single Dante network between multiple rooms. This is really where Dante or many other platforms has moved us, is to be able to deploy either a large core DSP or multitudes of DSPs, but they're all interfacing to one another and very easily, not using splitters or very expensive routers or anything like that. And one of the things that we're looking at here is this is actually a Dante domain manager system. Now that might confuse the waters a bit, but we're going to go over what DDM or Dante domain manager is a little bit later. But what this is what we kind of see now is where you'll have a segregated boardroom in one side of the building that is all Dante interface, and then another one and another one. They have the ability of interfacing with one another. The other thing that we get with the DDM side of this is how you can isolate these rooms down to being a standalone Dante system that has its own master clock, its own systems, where if it failed, it wouldn't take down other things. But that's really highlighting DDM in itself. But what I wanted us to gain from this is how we moved from having a singular room, singular DSP, to having a room that runs digital signal, and then the ability to interface these to multiple locations. And this is kind of what you see now, the going forward for install industry on large scale, is that it's all networked AV. Now, looking at the software platforms, this is focusing now on the Dante software platforms, the various ones you get out of them. And I really wanted to do this because there are some of these aren't really highlighted as much, or you might not be aware of them. And you might be like, great, I'm looking forward to using these. So the first one you have is Dante Controller. That is obviously the most common one. That is what we use to control Dante, the routing and monitoring it from a very basic perspective. But that is the free application that you can download if you have an account with Dante. And it gives you the ability to set up Dante and control it and monitor it. Quite powerful, and it's predominantly what we're going to focus on right now. Then the Dante Virtual Sound Card is DVS, as it's commonly known. It's been around for quite a long time. I actually remember when I was still in university that just came out and we were using it then. And what this does is it allows you to turn your laptop or computer into a recording device and a playback device of up to 64 channels of audio. It's really big in the live industry in a way because it allows you to multi-track audio straight off of Dante devices. And some places we do see it being used in boardrooms where they use it as the sound card to Zoom or those kind of things. So the computer will recognize it as a sound card and it will use it as a sound card. But now what has been added in recent years, this isn't entirely new, but it is a bit under highlighted, is Dante Via. Dante Via sets the tone for what we'll see going forward, and you'll see it in the next step in the hardware stuff. Dante Via allows you to convert any hardware I/O that's on your computer, your speakers and your microphone. Every laptop has got a microphone and a speaker on it. Dante Via allows you to take that I/O, that microphone and those speakers and convert them into routable places in Dante. So you can send Dante audio straight to the speakers or take microphone straight to Dante. The difference is that with Dante DVS or Dante Virtual Sound Card, you couldn't actually listen to the audio on that laptop. You could only receive it and then play it back later. Whereas Dante Via will allow you to be able to listen to the Dante streams and play back into the streams. The other big thing it allows is Zoom or any other application for that matter, not highlighting specifically Zoom in this, but it allows you to directly route from the application. So when you have Via on your computer and you start up Skype or anything like that, you can select it to directly pick the audio from the application and send it straight out to Dante, whereas Dante Virtual Sound Card comes up like a standard sound card. So all Windows bings and bongs will come through too, whereas here you can isolate it a lot. Dante Domain Manager, now I briefly mentioned a bit about this, and this might be the last few times we hear of it in this side of it. It's a very, very powerful application, and in a lot of situations where people feel that Dante is not fulfilling their needs from a large deployment side, DDM is the answer. DDM enables a lot of functions that you don't get with normal Dante. One of them is layer 3 networking, so Dante can operate on a layer 3 network. SMTP capabilities, so for broadcast industry, SMTP 2110 standards, you can do that with Dante. If you have DDM, fault monitoring to a whole new level, subnetting, domains, and high-level security. The domains is the big one where you can segregate Dante down to separate domains so that when you open up Dante controller, you log into one room and that room will only show you the components in that domain. So what it allows me to do is to make a boardroom that has 5 microphones in it, and I'll only see the 5 mics. And I'll see the audio going out to the main core DSP, but all the other rooms I can't see. And in the other rooms, the same situation, I won't be able to see the other rooms. The other big deal that it does for this is it creates a master clock per domain so that if you have a fault or a failure in one room, one domain, it will only take down that one segment. It won't take down the entire Dante network. Quite powerful application. It's something that we distribute and sell in New Zealand quite happily and very proud of it. Now, the hardware platforms. Now, this is going to get very interesting. What I really wanted to cover here is what are the different hardware platforms, not the brands, not BSS, not whatever brand you can think of, but what chipsets are inside the Dante hardware and what limitations those chipsets have. And I'll explain why that is as we go on. Now, from the core of it, we need to understand a few things about Dante. This is a typical Dante card. It has a primary and a secondary port, and it might have a word clock out on it. The primary port or the single port is where the audio will go in and out of, so that's your main connection. And a secondary port is commonly used in a secondary network setup. So it's the redundancy port. What this port normally involves if you want to set up a secondary is you have to set up 2 completely separate networks. The idea behind that is if you had them running on the same switch and that switch went down, that's a single point of failure. It's not redundancy. Whereas if you have 2 separate switches running to all the different devices and they're running completely separate from one another, one can go down and it won't take down the other. And that's really how this primary and redundancy stuff works in Dante. But what there's also to the secondary port we'll look at later is a mode called switch that we'll cover. But the other thing that I want to highlight is this fantastic backup plan that I want to teach you guys. If you're a technician and you work with Dante products deploying them and you've run into issues with IP stuff, I'm going to tell you a way to get through to fixing it when you've completely buggered up the device. The other function is worth knowing is that typically these cards have a word clock out. So word clock out is a method of syncing, clocking. We're going to cover it in detail later, what it does, but whatever clock is coming from Dante onto this card, it comes out that port. So if you wanted to clock a device to the Dante network, you would use these word clock outs on them. It allows you to do that. Now, why we want to look at that card is to understand the different chipsets and what these functions mean. So over here, we have a list of all the current Dante hardware chipsets there are. Now, depending on how much you know about Ordinate, or Ordinate's the company that owns Dante, they develop the chipset and the company, be it BSS or whoever, buys that chip and puts it in their products. So they control the hardware deployment part of it from the chipset aspect. And these chips are generic. So in many ways, the ultimate chip that's inside a Teratic and the ultimate chip that's in a Sure, DSP is the same ultimate chips in that case, specifically if you got the exact same model numbers, but there isn't some special source that someone can add. There's better deployments of it where they utilize the chipset functionality much more, but it still comes down to there is a chip and that chip has limitations. So I really wanted to get this across the line and show you guys what we're looking at, because this tells you very easily, is this product capable of this or not? So first up, we have the Ultima chipsets. I'm going to just break this down for you. I'm going to list models, channel count capabilities, flows. Flows are how many times can it create an audio stream to a device that is in a different direction. Quite complex to explain in that manner, but I'll cover it a bit later exactly what it means. But think of it if this device can only send its audio in 2 different directions before you have to start using multicast, and then even if you do that, it will only do 2 multicasts. That's kind of the explanatory behind what these numbers mean. Redundancy, does it have that redundant port? Is it a function it could do? And then the Ethernet port, what speed is the Ethernet port on these, which has got to do with your bandwidth limitations. Moving on to the next thing is common products. So some of these I was able to find a common product that you would be able to relate to. Some of them I can't because the products are too new or it's quite convoluted what the product might be. So let's go through this very quickly. Ultima. Ultima is typically what you find in a TeraTech. It's a 2x2 to a 4x4. It allows 2 flows and it has a 100 megabit port. Very important to know this with the type of switch configurations and stuff that we'll cover a little bit later. Dante adapters, those Avio adapters that you've probably seen by now, which are very cost effective. This is essentially the cheapest form of Dante. And once again, what we need to know is their 100 meg limitation. Broadway is quite a new one that's come onto the market. It's effectively a cheaper version of a Brooklyn chipset. It has 8x8, 16x16, so you can see the limitations it has. But moving forward to the Brooklyn 2 chipset, this is the most common one you find. This is what you find in DSPs, mixing consoles, a lot of larger scale ones where they're going to use larger numbers like 8x8, 32, 64x64. Just for interest's sake, the Shure ceiling tiles, for example, they use the Brooklyn chipsets. The BSS Blue 806 uses a Brooklyn chipset. That Soundcraft card uses one. So most of them are using this, and it's a 1 gigabit capability. Then you have these new ones that have started coming out. Dante High HC is another form of a chip-based one. It's a 512, so a massive amount of channel count, 128 flows, and the only product I know currently that has it, there might be more, is the Allen and Heath Dante card that's been recently released a few months ago. There's also now the new, now this is where things change, is Dante's kind of where you see Dante Via going into the next level. Dante IP Core is a software-based deployment on a computer, not a Windows-based one, but a computer or a core that runs a Linux background essentially, or some other forms like that. So this is just like having the HC, but a software-dependent one. And what we can see here is also very high capability of channel counts. And obviously the Ethernet port is dependent on the hardware that it's deployed on, but currently they give an indication of 1 gigabit. Now, to date, there hasn't, or as far as I'm aware, there has not been anything just yet because it is quite new. But in the future, you're probably going to find that most big scale DSPs will move to this platform. Dante Embedded, also quite a new form. This is what some of you might have actually seen this already, but this is what the Shure IntelliMix software-based is using, is an embedded version of Dante in the software code. So it's like a light version of the IP core, but it runs within the software code itself, and it's got a very high capability. But the Shure IntelliMix is the first product, or one of the few. There's only currently 2 that currently have it, but that has that done on it. So another software deployment. Then Dante AV, this is what we know as Dante Video currently. Dante Video is actually a chip. It's not a brand. It's not them selling a video product. It's them selling a chipset that other brands can use, same as what's happened before. What's interesting to know is a little bit I could dig out about it is it's an 8x8. It potentially has 8 flows. I don't know this for certain because it was quite convoluted. I don't know about the redundancy port, and it currently has a 1 gigabit backbone. But there is quite a lot around the Dante video stuff. But it is interesting to know that it is a Dante chipset, and it's deployed by a brand that wants to use their chipset. There's a lot more information into that you can dig. Dante application library is a very light version of what you would see embedded. So in the future, very far future, maybe sooner, you will see Zoom or other applications, not saying Zoom will do this, but applications like that using an embedded version of Dante in the application itself and more. And that's being allowed for, because this is quite new and we haven't seen anything. Once again, I don't know any information about it. Now, from the live industry, this is really useful to know. Dante DVS is a fantastic piece of software, but it is a software and it can crash. Dante PCIe sound card has been out for ages. There's Focusrite, SSL, various brands that do this. And it's essentially a PCIe card that gets installed into your computer and you can record multi-channel tracks. It's a hardware dedicated, so it's much more safe than DVS is. Not that DVS is bad, but this is a much more safer deployment of that. That kind of covers all the current chipsets that there are. So I hope that was quite useful and insightful. Now, digging into the bones of what Dante is. So we're going to go through all of the following: quick overview, LAN setup, device naming, routing, device info, clocking, latency, and UniCast, multicast. So a quick overview of Dante or Dante controller. When you open up Dante controller, this is what you get presented with. Obviously, this is populated with devices. And the main thing you need to understand is that you transmit the audio and you receive the audio off of the device. So what we have here is a screen grab that gives you a lot of information about what all these tabs mean, but all the transmitting devices here can send to any of these receiving devices. And you can also transmit one device to many devices. So it creates quite a beautiful splitter. And very cost effective compared to what the live industry splitters cost, or especially used to cost. This is why live industry loved it, because it was a way you could distribute audio really nicely. Now, things that you would like to know is these little icons that pop up. So those of you that have used Dante will know that when you do a cross point, you click and it activates. And sometimes this doesn't go to plan. What do these little things mean? So if you get this hourglass, it means that the subscription is currently pending. In other words, it's trying to activate the subscription. When you click there, there is a commit between this is sending data packets to there, and they have to address and request it between one another. So that's essentially the process that's done when you do that click. Then there is the subscribe, which means it's functioning perfectly fine or established. There is the warning sign. Some of you might have seen this. This comes up typically if one of these units drop off. So let's say I'm transmitting here and this unit here falls off the network. That little orange square comes up, which means the hardware is not there. It can't transmit the audio. But the beauty of Dante is that when that hardware boots back up, it will automatically do the subscription again, or it should, unless the network prevents it from doing that. Very uncommon that the network will, but it auto subscribes back and it should go back to normal. The other thing is the error. So this no-go sign, when that comes up, it typically happens when either the bandwidth of the port is exceeded. In other words, the network is too congested. And at that point, when you did the commit, it couldn't do the link between the two. In other words, there wasn't enough bandwidth to commit it. The other side that I've seen that happen is that you sometimes do it and it fails. And it happens when someone takes a piece of hardware that came off from another site and was subscribed to something else. So I go from site A to site B and I put site A's box into site B. And site A's box still has remnants of the previous connections it had. Now, yes, it will fault. It should give you that in the window on the other side of the device info tabs. But what you'll find is that you'll try and recreate the subscription. In other words, let go of the previous one and it won't work. So the way to fix that is you need to go into the transmit or receive, depending where the problem is. You do that by double clicking on the object, and you just need to click on unsubscribe. Now, later on, I'll show you what the unsubscribe button looks like, but that's essentially what's happened. It's just because it has remnants of what's happened before. Pending, if you click on that, well, if you get the pending sign, the clock, it just means that it's taking a little bit long to commit, and that could also be due to network latency, or it will eventually commit. If it doesn't commit, you're going to get one of these error lights as it is. Moving on from there, device naming and routing. Now, this always comes up quite interestingly is what is the restrictions with naming and routing within Dante? So first thing I want to make you aware of is, remember I was just talking about the receive and transmit. Those are the tabs you see. So when you double click on the product, it will pop up with this device view and you get this receive and transmit. And over here are the channel commits. So if you ever end up with that problem I said where it's remembering something it shouldn't, you simply highlight the ones that do that and you hit this unsubscribe and it unlinks those. It wipes that memory. If you also clear the config on the device, it wipes all of it, but it just cleans out the trash that was left there from before. Now, naming. So Dante naming is extremely important with devices. It's a really big deal. Why is it a big deal? Is because Dante uses naming to do routing. So when you call the box FOH-desk, that is used as part of how it routes audio from one place to another. If you change the name, it will lose the routes because it needs to reestablish based on the name. So treat the naming of Dante as if it was the IP addresses of the product. So treat it in the same sense. One, obviously you can't have duplicates of IP addresses, so don't name boxes the same. It's pretty clear that it won't work. But more importantly is that you need to maintain the naming and commit to it and keep it going as good as you can, especially considering that that name is essentially the way it does the IP routing. Now, there are some rules around this. First one is Dante is in case sensitive. So when you name something Mike and use a capital M to differentiate between the two, it doesn't see that as a difference. It's still the same box. So whichever way you write the name on the product, so here, for example, this is where you name it. You type it in there. If I use lowercase for this, it's still not going to allow it. So first thing, in case sensitive. Next up when naming is that you can only use A to Z, 0 to 9 or 0 to 9, and dash or underscore are allowed when naming a box. You can't use any special characters when doing it. The next step down from that is when we talk about channels. So same rules apply with the in case sensitive. Most of the rules apply with the A to Z and so forth, but a few extra things get added. Channel names, you cannot use equals, full stop, or period, or at. The at part is really obvious in the next thing, but those are not allowed within the name, so you can't use those. The one thing you can do is the names for the channels are independent to the device. So I can have one device that says mic 1, and then I can have another device that says mic 1. I just can't have mic 1 and mic 1 on the same device. I hope that kind of makes sense, but essentially you can't use the same names again as a channel on the same device, but you can use them on multiple devices. So you can have preamp 1, for example, and up to preamp 18. Why is that? Is because the way it builds it. So this is essentially how Dante differentiates its naming, is it will become channel at device. Now you understand why we can't use at, but it's, yeah, as the example is mic at DSP. So the example here would be Vox 1 at stage box -1, for example. So you can kind of see it in the naming, but you get the idea is that that's predominantly the rules around how it goes with the naming. Next up with Dante is the LAN setups. Now you get to site, you want to use your laptop. If you're like me, you've got 4 laptop Ethernet connections. Bear in mind my laptop, those are all USBs. I don't have an incredibly fat laptop. But there are multiple connections. So how do you change that? Well, when you open up Dante Controller, right here in the top corner, you'll see this connection. You click on that, it brings up this window. And in here, from the drop down, you can select which Ethernet interface you're using. So on mine, I think there's almost 10 of them, because it shows you your VLANs and everything. And you can select which one you're going to use. When you select the one, it'll immediately show you the IP address, so you can make sure you're in the right IP address for that device or go change it. Also shows you the port speed. So that's a 1 gigabit. What is useful to know about this is that it'll show you if you're on a Wi-Fi or a VLAN or something like that. The symbol changes based on what it's doing. Likewise for the secondary, you set it up here also. Another nice way of accessing this is you'll see down here in the primary and secondary of Dante Controller. You can just click on that and this pops up. Now two things that I really want to show you guys or tell you about is that the Wi-Fi. Wi-Fi used to not be supported by Dante, and it is actually supported, or it's been for quite a while. You can do Dante routing with Dante Controller over Wi-Fi. You can't send audio over the Wi-Fi, but you can manage the Dante routing paths and monitoring through Wi-Fi. So if you use shared devices and stuff, you'll see Wi-Fi comes up and you can select it. Now, the other thing that also has always puzzled me is what does this use shared device Dante interface do? Well, When you activate that, that'll allow you to select a port that is shared with another Dante application. So if I've got DVS on my computer and it's using Ethernet 1, I can't see it on this drop-down list until I tick that. Once I tick that, then I can see it. If I select it, it will set Ethernet 1 as the default Dante port for all applications that are running Dante. So quite nice to know that answer finally. The other thing I do want to make you aware of with Wi-Fi is you do not want to do firmware updates over Wi-Fi. It's extremely dangerous because Wi-Fi drops out, and if you drop out mid firmware update, you're going to brick a device, which is quite painful. And then AES67 is a little bit susceptible with Wi-Fi because if there's any multicast filtering on the Wi-Fi at all, you're not going to really see any AES67 streams. So just bear that in mind. Next thing is setting a device IP address. So when you go and double click on the device, it'll pop up with this, and in here you can select your IP addresses. Now we're looking at a Brooklyn chipset specifically here, so it's got a secondary and a primary, and it's currently in redundant mode. If you click on this drop down, there's another mode called switch, which I'll explain towards the end of this. But what we want to know is this obtain IP address automatically is effectively DHCP or auto IP. So when that's activated, it's either going to take a DHCP IP address that's dished out by a switch or a server, or it will default to a 169 address. When you select manual, then you can type in an address, a specific IP address, and apply. It's going to force you to do a reboot, and then it'll reboot and the device will come up. During that time, you have to hit refresh like 100 times, and eventually it comes up. But that is how you change the IP addresses. What I do want to suggest you do, if you're not going to touch the secondary or use the secondary network, do not touch it at all. There is a really nice function about this that you can use it as a safety net. Following when you do these changes is this switch port mode that I mentioned. So on this drop down, there's an option to select switched. When you activate redundant, what that does is all the audio streams that are going out the primary go out the secondary. It duplicates the whole time. And as I explained, it expects you to have a secondary network. When you put it into switched mode, it turns into a 2-port switch. What that means is if you have two devices, one device, one DSP and then another DSP, and you connect Dante between the two of them directly, no switch, then it will obviously work. But now how am I ever going to do the routing if I've got one direct connection and no switch? Well, you can, if you're in the switched mode, you can plug into the second port and that'll allow you to access everything on that. It creates a daisy chain, so it'll allow you to see the other device through that. Switched mode is useful for live applications where you have stage box to console and you want to access the other side of it. Or more importantly, if you have other situations where you just don't have a switch and you want to create it a little bit reliable, it's good to know. The important thing I will tell you is that if you're in switched and you plug both ports into a switch, it's going to freak it out because it's going to create a duplicate LAN. So just be aware of the modes that you're in at the time. The other part is that sometimes you'll end up on an install and someone's gone and plugged in the primary and the secondary, and doesn't matter which mode it is, and it's going to freak the switch out a lot. But just bear in mind that secondary port shouldn't be plugged into the same switch. Now, this has been added for a very good reason, because it happens to me a lot, and I'm sure it's happened to a lot of people, is the oops factor. So oops happens when you change the IP address to the device and it's the wrong IP address, or you changed it and you forget one little crucial factor. So this window comes up when your computer's IP address is not in the same range as what the Dante device is, the port that you're looking at. And very simply, how you read this is the IP address of the Dante device. So if you're trying to figure out what its IP address is, it's this one. And your computer's IP address is this one. And we can see these two are out of range. That's why it's not functioning. So immediately I know if I want to get control of this, I need to move my computer's IP address to that same range, and then I'll be able to access it and fix the problem. The other reason this might happen, and this gets a little bit more to the fun stuff, is if you have DHCP set up on the network and your computer's taken a DHCP based on a lease or some sort, and your Dante device hasn't, they're obviously going to be in different IP addresses. This error comes up. Or what is more common is you set up two different DHCP VLAN systems, and one gets designated this IP range and the other one gets designated a different IP range. This is how you can tell that issue is happening and you can fix it. So the takeaway with this is really, this is the IP address for the device. So if you're trying to figure out what the heck it's gone to, and that's the IP address of your computer. Now, I mentioned there was this safety that you can do with the secondary. The secondary port, as long as you don't touch the settings, can access the primary port settings. So what that means is that if you've completely destroyed the primary settings, which happens, or it becomes impossible to access the primary through the network, you can simply plug into the secondary and access the system by changing your port, that's this bit here, to the secondary network. And it will then give you the settings for that primary network, and then you can go and change the IP addresses and fix the problem. Really useful to know, and it's saved me a lot, especially when network switches have caused a huge amount of drama and I've lost the IP address completely. Now, device info, this tab is really useful. I get asked a lot, how do I find out all the IP addresses for the Dante stuff? I do it a lot because I completely forget it's this tab. Why do I forget it's this tab? Is because network status seems so logical to show all the IP addresses, but it's actually device info. So this window here is, you have the routing window, then you have the device info window. So when you click on this, it will give you all this information. It shows you all the IP addresses of the devices, so you'll be able to see it. But what we also have is a few other things that we want to look at, namely Dante firmware version. So over here, I can see the Dante firmware version. Now, a question that does come up quite often, or I see people doing, is updating Dante firmware, because it's sometimes, in many ways, it is standard practice in our industry that if we do a deployment, we have to update the firmware for all the equipment on site, which is true in many, many situations. However, Dante firmware, this version is referring to the Dante chipset. It's not referring to anything to do with your DSP, and they normally get done separately. And when you do a Dante firmware update, it's really risky. And one of the things that Dante is very good at is, in a very generalizing term, the firmware that's on there is normally perfectly fine. And if the system is not broken, don't touch it, leave it running as is, and don't do the firmware. So unless there is a feature that you require that the Dante firmware will enable, or the manufacturer of that brand told you to do the firmware update, you generally don't do the firmware update unless you have to. A such example would be, you'll notice these are all on version 4. That means that most of these will be compatible with DDM. So if I had to deploy this as a DDM system, sure, I would have to then update the firmware on these devices. However, if I didn't, there's no reason to do the firmware update. The reason why I'm being very particular about this is Dante firmware is very dangerous when it comes to those ultimate chipsets, because they've only got one port, and once it goes wrong, it goes really sideways. But just something to be aware of. Be wary of the Dante firmware. Back to the next thing. Device lock. If anybody activates a device lock, you'll see it here, and you can deactivate and put the password. Primary address, as I explained, you can see the type of primary address. The primary link speed, this is really useful to see this. This tells you what is the speed of that connection. So if I plug a 1 gigabit capable device to a 100 megabyte switch, you'll see this will drop to 100 megabytes, and you'll know that those devices are not operating optimal. This really becomes obvious when I talk about bandwidth a little bit later, but it's good to know that that's where you can see that. And this populates the secondary information. For interest's sake, the secondary port of Dante always defaults to 172.131 as a default IP address if it doesn't get given an IP address by a DHCP server. It doesn't default to 169, which is useful to know. Clocking. Now, this is where we're going to get to the detailed stuff about Dante. So if you're familiar with clocks, clocking in digital audio realm is like a heartbeat. If there is no clock, the heart stops. Well, if there's no heartbeat, there's no heart, there's no life, right? Same thing happens in audio. You start ending up with issues and things like that. So clocks are really important with a digital audio system because it's what's used to reproduce the waveforms and everything on the conversion stage of the digital process. What's useful to know is, how does the Dante clock election system work? So this is a priority system from 1 to 3, but predominantly when you plug in all your devices, it's going to auto clock. In other words, it'll pick its own master clock. And something, if you're not aware about Dante, or actually any digital audio system for that matter, is there always has to be a master clock. Something has to be king of the clocking systems. And you can only generally have one running. So this is how it will elect it, is on the lowest stage when you switch on all the gear and you don't elect a master clock, it will auto select the clock based on the MAC address. So the highest MAC address becomes the master clock. Then moving a few steps forward to preferred clock master, this is a feature you can enable. In the next slide, I'll show you where it is, but you enable this and it says this device will become my master clock, and it will always default to that unless there is a problem. Now, typically what that would be is the most reliable piece of hardware that has the best Dante card in it is what you would use. And that typically is your DSPs. More importantly is which one will never be switched off. And once again, that is commonly your DSP. So during the deployment and things like that, you really want to use your main DSP in an install realm. In a live mixing realm, you want to use the main front of house console. Or if you have a very good system, you'll have a master clock distribution system, which is a dedicated clock that you'll feed into Dante, and it's a very big system. But you would activate that as your main clock. Now, from preferred clock master, if that's not activated and you've activated sync to external, it will default to that as the master clock from there. The sync to external I'll explain in the next slide. But then if that's not activated, it will go to the auto clock. So what does this look like? When you click on clock status, you get this window. This gives you quite a bit of information. Now, before this becomes a bit interesting, I will need to let you know this is a DDM system, so it sees two domains here. I know this because I can see domain up here and someone's logged in, but there is a reason why there's two masters and a main, which I'll get to. But focusing on where's the masters. So first thing, clock status, this tells you if it's in sync or not. If it goes red, it's going to mute the device. You'll see it says mute and you'll lose audio. Essentially, if there's no clock, the device can't operate. It will create network instability and Dante kills the clock and you'll see a little red square. I know many people that have used Ultimate chipsets in the beginning will very well know what I'm talking about with that little red square. Clock source is which device is the clock source. So in this case, it's all Dante. If you enabled external, it would say external. Domain status. So this is with DDM. DDM, as I said, it can have multiple clock masters. We can see that here, but that's currently the main master clock for the system, which leads me on to who is the Grand Master. Up here tells you who is the Grand Master, who is the primary clock for your entire system. As the changes, it will update here. Interesting enough, if you get a MAC address up here, which I've seen quite a few times, that actually means that part of your multicast setup is filtering out the information and it's not getting the full name. I only recently learned that. I kept seeing it, now I know. It means there's a switch configuration issue, or your firewall on your computer is filtering off the multicast data that assembles that clock information. Then who is master clock? Obviously it will say master. Then which device is preferred clock master? So as I told you, I'll show you where you enable it. So if I tick this, this becomes the preferred clock master. And then enable sync to external is here. This is where you enable that. You can have multitudes of preferred clock master, so I can activate 3 of them or more if I want to. It will always default to which one's the most reliable and highest MAC address when I do that. So now looking at sync to external, what does this mean? So typically how a Dante system works is your main DSP or whatever you set as the master will distribute the clock to all the other devices in the network. It's important to know that it's actually the Dante chip that is doing that. So it's not your actual DSP that does it, and depending on implementation, it is the Dante chip inside the Brooklyn or whatever it is distributing the clock to these devices. Sync to external enables that if you have a DSP and your card is installed in there, that the external DSP's clock will clock the Dante card in there and make that the master and then clock all the others. Now, I'm pretty sure that makes sense in a way, but a few scenarios. I have a Blue 806. It's the most reliable DSP. I like its clock. I want to use it. I click sync to external. Then that will be the clocking device for the Dante card in my Blue 806, and then that will distribute the clock for all the other devices in the Dante system. We use this on a number of sites. One of them, for example, has got BlueLink, Kubernetes, and Dante, and this is the way that we have Kubernetes clocking Dante is through an 806 Kubernetes clocks. Kubernetes goes from a Blue 800 clocks a Blue 806 through BlueLink. The Blue 806 clocks the Dante clocks all the devices. hell of a dream to work on that one. But that's an idea of where you might use that. In the live industry, you use this a lot where you have your main mixing console or your main distribution clock needs to clock a Dante card, and then it clocks all of them. So what I really wanted to highlight here was that just because you set that card as the main master, it's not the master running off of the actual hardware's clock, it's running off the Dante chipset's clock. Latency, timing is everything. So a little bit of riff. What is latency? Latency, we know, means that data is arriving at a late time or something, or at least when we talk about switches, that's what latency is. Now, how does latency affect Dante and what causes latency? So in a network switch, there's various things that can cause latency, but what predominantly is if the switch is a bit flooded or there's a lot of data going on through the switch, it will start delaying packets and they'll arrive later. What that means in Dante world is eventually the packets will come so late that it won't allow the audio to pass and it will mute the device. So what we see here is an example where you get regular timing from what gets transmitted, and then when it gets received, it might receive it at weird intervals. Now, how this affects all of us and what it is useful to know about it is that there is this setting that you do in the device config that helps you state what is the maximum amount of latency allowed. Now, you'll notice here that not all options are available. On Ultima chipsets, they definitely are not. I think they only go down to 1 millisecond, some of them. But you'll see that it's dependent on how many switch hops. Now, the more switches you introduce, the more latency is, because there's basically a conversion process that has to happen, right? Data needs to move from one place to another. It takes time, it adds latency. So these are just recommendations here. But one of the really useful things to see is 1 millisecond, 100 megabit leaf nodes. What that's referring to is that if your switches or your devices from Dante are 100 meg capable, Ultima chipsets, or any of your devices are running like that, you want to use that setting at a minimum or more. So that is really where you start increasing that amount. What this is a safety window. How far will Dante stretch before it cuts audio off? So you'll see that in the next illustration of what that looks like. The other thing I would like to make you aware of is that when you enable external clocking, like I just showed you just now, the Dante device actually does an offset, so it will go into the negative of the timing scale. It's offset of like negative 200 unipascals. And what that will do is shift everything else in time, so it needs to use that window to move. The one thing I can tell you is the higher you increase this amount, it doesn't affect your system. You're just creating safety for yourself. The lower you go, the quicker the packets are received. So for an install industry deployment, I really do recommend you use higher settings. In live industry, the closer you get to the lower the number, the higher the risk, but normally you're not doing a lot of switch hops, so you're normally quite safe. But how do you determine what this all means? Well, in Dante, there is a latency monitoring windows, which this illustrates to you. And these are the most useful tools when you're fault finding. I use them a lot to help people fix their Dante issues. But what we have is a measurement of latency. Now, to get to these, this one here in particular is the useful one. You need to click on that there, clock status monitoring, and it opens that window up. And from this drop down, you can select which hardware you want to look at, and it will give you the latency. There is also another tab inside the device view, which these are derived from, that shows you all the transmissions, but it isn't as much information as this is, and I'll explain what those come down to. So what are we looking at? A very good situation, you will have no late packets whatsoever, and everything will arrive, and you'll have one bar, especially one that's lasted for this long, 7 minutes. That means that you're receiving very few issues, and it's running really, really well. Then as you get up to a normal situation, you'll end up with a few more of these where the packets arrive a little bit late, but they're not perfectly in line. And you'll notice that nothing's gone late, nothing's gone red, so this is perfectly fine. When you get that mute status happening, that's when this happens. So you'll see this red bar starts popping up, the device will mute. And the reason for this is that this device is set to 1 millisecond as a maximum. You'll notice here this peaked at 18,000. But what's really useful to see is the late. Over a ridiculous amount of packets arrived late, and it got lost. What I do want to highlight to you is that this collection of data only happens if you leave Dante controller open on the network. This is not captured offline. You have to have Dante controller plugged into the network, running online on a laptop, and it collects all this information. If you have a serious problem like this, you'll see the information collected very quickly as soon as you clear it or anything like that. What adds to these problems? The most common one is EE. So if you have EE enabled, that's the energy saving protocol that you find on switches. That causes this issue because it downgrades the speed of the port to save power. The other one is network load, latency, distance hops, or when a packet is being interrogated. So I've seen this happen quite often when the clocking packet, which is a multicast packet, gets interrogated quite a lot by the switch, or the filtering's not done correctly, and you end up with this happening quite a lot. So the next thing is, what does all the little things on the sidebar mean? So I really wanted to give this to you guys as a nice illustration, much larger, bigger screen, good. What this latency setting is for the device, so when we see how this is what you've set it to, 1 millisecond. Now remember I said that's your headroom, so depending what you set is the highest amount that it'll be okay with. If I set this at 5, it would allow up to 5 milliseconds of latency. The peak, this tells you what was the peak during that period, so that gives you the worst case scenario, which is pretty bad in this setup. The average, 1 millisecond, and then how many packets were late and how long was this running for. The really important things to see here, because sometimes people open these bars and like, wow, that bar is big, but then you forget to look here on the side and see how many packets that was that it picked up. So this is the packet count. That bar starts growing logarithmic as you go. And then this is the maximum amount, so you can see how it's drifting. So like here, for example, it was drifting just below 0.4. If you've got negative offset, you'll see it go even further down than that. So that's how you read that window, and it helps you to figure out what is the problem. And it's clearly indicating to you there's a packet issue with the switch configuration that you need to look at. Now, UniCast and Multicast. Bandwidth. Calculating the data bandwidth usage on Dante. So I've very often had people think that a network is not going to handle the amount of data that Dante is going to use. And very seldom do you actually get given this is the amount of data that Dante is actually going to use. So here's the math, very straightforward. 64 channels of audio, so that's 64 channels coming off of the Dante card at 48, 24-bit. So 48 is commonly how everything is sampled, that's your sample rate, and then your bit depth, which is the dynamic bit depth. And then you have the math times 64, the amount of channels. So that works out there, and you end up with 74 megabits. Now you have to hinge a bit more into it because there is other things on the network. So effectively 96 megabits. Really eye opens it up to you that 64 channels of Dante being sent from one device is only going to total 96 megabits. It's nowhere near a gigabit network, but it is close to 100 megabits. So it's good to know when you're pushing it. Now, you may recall early on the ultimate chipsets are 100 megabit, but they can only transmit 2 to 4 8 channels maximum. So you're never getting to the 100 megabit limit. So Dante has thought about that, but remember what I mentioned is that if you plug a Dante device into a 100 meg switch, it's going to downgrade the port on the Dante device, and that's when you're going to run into issues. So it's good to know this. Also, when we're working with 512 plus channel distributions, it's good to know what the actual amount of data is going to be flying around. Now, does that amount mean that that's one part load? So if I had one device, is that going to stick 96 on it? And what happens to this audio stuff coming in? So we're going to look at that next. How does this look in a switch? So this device here is sending 64 channels of audio, so 74 megabits and down to the raw number of it. And that means that the port that that's plugged into will receive 74 megabits. Now, at this point, it's good to know that when you read 100 megabit full duplex, what that means is 100 meg in, 100 meg out. So it doesn't mean that the 74 is going to consume everything and I can't receive an RX version of that. You'll be able to receive all of it. But what's good to know is that in general, if you're using UniCast and if you're deploying multicast correctly, this will only transmit to the devices that request it. So what I wanted to show you here is this is only doing 2 channels of RX audio, so it's only receiving 2 channels, therefore it will not receive the full 74, it will only receive 2.4 of that distribution. Likewise for here, this is sending and receiving, so it will only receive and send what it gets. And the same for the 64 channels of RX on this device is receiving all of that, it will only receive that. It's not going to receive other combined amounts. So what's useful to know there is how this actually works in terms of total bandwidth. And this really clears up some of the confusion because I, for example, have done a Dante distribution with 11 times 64 Dante distribution. So that number is extremely high. I think it's 768 or something like that of audio channels flying around a network, and it was perfectly fine because it's very low bandwidth, because it was only 64 going in certain directions. So you can run up to 1,000+ channels easily into between things, because it's only the audio that they're requesting and receiving. Now, how that differs from multicast and unicast. So a little bit of an understanding around what unicast and multicast means, very basic terms of it, is typically Dante operates in a unicast. So when you go on purpose and create a route between one point to another point, it will only send data from point A to point B. So when you go and click on Dante and you do your first route, it's unicast. It's not multicast. You have to force the multicast to happen. What that does is that will send the audio only to that place. So device A and device B will receive audio. All the other devices will not receive that audio. Broadcast, which is not part of how Dante normally operates, is that it will send audio to all places. Multicast is where it will send the audio from one device once to multiple locations that requested it. So these devices here, device 2, 4, 5, I should probably count that before I did this, but 2, 4, and 5 will receive the audio, the others will not. In other words, those things will not receive any load. Now, what makes this different is that when you commit a unicast, it's a singular stream to a device. So when this device requests that, it gets that. When this device requests that, it gets that. When this device requests that, it gets that. It's singular. But notice this creates 3 streams from that device or devices, so lots of streams. Now, Dante will do this thing as soon as you exceed more than 2 flows. It will tell you that there's a fan out error. Now, fan out error, I used to assume in 2 channels or more. What it actually means is that how many routes are you doing? So if I take one channel and I distribute it to one device and I send a few others up to 4 per flow, it will only be 1 flow. But when I create a second flow of the same things to another device, then that is 2 flows. And when I get to the third one, it will create the fan out error. What that means is that it has to create multiple unicast distribution happening. So as soon as you exceed 3 flows, it tells you that it has a fan out error. And what that really comes down to is that there is a more logical way of doing what you're doing, and that is using multicast. So in Dante, you can activate multicast, and you can send the audio that you were going to send through a multicast, and you still route it the same. It pretty much looks the same, but it will create 1 flow and it will send it to as many directions as you want. So this is a great example where you take one microphone and you send it to 16 different places. It's more effective to create a multicast of that. Now, how do you create them? Well, in this window, you double click on the device that you want. And up here on the top, I've blown this out quite large so we can see it, but you click on that and that will create this or open this window called the multicast flow window. In here, you select the channels that you want to add to the flow, and then you create them, and that will create the multicast flow here. Now, as far as Dante routing goes, it pretty much knows now when you're clicking around and routing things where things are going. So the routing procedure is not any different. But when you're using AS67, that's the multicast address that it's going to use. You might not have seen this depending when you've last used Dante controller in AS67. This has recently been added. Is Dante can now do 64 channels in a single multicast packet being distributed. Now that would amount to effectively 72 something megabytes or 96 megabytes of data being thrown around to every device that requests it. But the other side is the AES side remains the same, where you can only create 8 channels go. So 8 channels a go. So when you activate AS67 and you want to send a multicast channel of AS67 to a device, you can only go up to a max of 8. And that's the ID that gets generated. So this is basically how you come up with those Dante multicast flows. And if you're working with AS67, this is pretty useful to know. What is also useful to know, if you need to delete them or recreate them, you just simply click on them and hit delete down here and it gets rid of them. So I highlighted something of interest there is you can now do 64 channels of multicast Dante across the network. Now that's a lot of bandwidth. And what's really important to know about multicasting between switches is that when you move from one switch to another and you're using multiple switches, depending how it is set up, it will always flow one direction. Now, we learned this in the Cisco training last week, but pretty much if you create a multicast packet and you set up an IGMP system, the main switch that is the carrier will always receive all the data. So you need to bear in mind that when you create that Dante 64 channels, you are going to shove 96 megabytes to all switches. So what we learn at this point is it's more wiser to create multitudes of smaller flows, even though you can do the 64, than one massive one that distributes to all switches. Now, what this illustration shows us here is that I create one big one. It ends up going to all switches. Even though the devices are not requesting it, the switches will still get it. And it's going to be overwhelming how much data is going. So the illustration here shows us that these devices only requested red and orange, and these devices only requested green and blue, but both switches are receiving everything. Whereas if you create multitudes of broken up multicast flows, you sit in a better situation where the switches are not going to run overload. It's imperative to know that because switches do have a CPU and they have a headroom, and multicast is a very heavy thing to deal. And the larger those packets are, the lot worse it's going to end up. So not saying don't use the function, just be very aware of what you're doing when using it. Switch config requirements. Now, as I said, this is not going to teach you how to set up a switch, but it's going to give you a really good idea of what you need to look for. So for a very small network, 8 devices or less, so I don't mean 8 channels, I'm referring to 8 Dante devices, you essentially can use an unmanaged or a managed switch. The main thing you need to do is it needs to have EEE disabled, energy saving needs to be disabled, or it mustn't have any EEE on it. It's quite hard to find switches nowadays that don't have EEE, but that's the main priority from the Dante requirements that you need to deactivate when you're doing a small system. When we move to a larger system, now this is still looking at just a Dante system, but more devices. The main thing you need to ensure is obviously the EEE part, but ensure the bandwidth is not exceeded between ports. So if you have ultimate chipsets and your bandwidth on the switch is being loaded quite heavily, bear in mind that they're only 100 megaports, and if you're trying to send a multicast packet that is in excess of 100 megs, you're going to flood that little device because it's going to request one multicast address and it will receive all of those audio channels that you've stuck in that big flow, and it'll end up flooding that 100 meg part. The other part that I want to highlight while I'm busy with this, it's more a converged network thing, but it's part of this bandwidth thing, is when you're doing converged networks, there's a lot of multicast data and you have 100 meg Dante devices on the network. Yes, the switches might be 1 gigabit, but the port will only handle 100 megs. And if you flood the network with multicast data, predominantly from not controlling it correctly, those those ultimate chipsets get drop off or have issues over time based on bandwidth usages. So if you are aware, it's a really good idea to monitor the load on the port, not the Dante part of it, so not the one you see in Dante controller, but what you would see on like Cisco switch management or SNMP, to make sure that you're not going over the 100 megs that those little ultimate chipsets can handle. Anyway, moving on to the next part of this. When you move to a converged network, that's when Dante gets more complicated. So Dante generally works perfectly fine with most switches, barring a few things that you need to be wary of deactivating. But a standard Cisco switch, for example, you can just stick them in and they operate perfectly fine. But where they start getting a bit flaky, or when settings are required more, is when you converge networks. Why this is that standards are required when you're doing larger multicasting. So because Dante doesn't use a lot of multicast data, you don't need to worry about IGMP snooping and static filtering and bridge multicast filtering, because it's not sending a large amount of data around the network when it comes to multicast. I mean, worst case on a 64, we're looking at 96 megs, which is not a lot of data. But when you start deploying it with video that can be in excess of 900 megabytes, that's when that multicast data will flood those 1 gigabit ports, because you're receiving the audio and you could be receiving the video. So you have to deploy IGMP snooping and bridge multicast filtering so that the devices do not receive the data that they did not request. So these protocols effectively are mostly around managing what multicast data gets distributed around the network. And AS67 particularly is in multicasting, so it also counts in that situation. What I really wanted to show you about this is that this is really when you're doing converging, you have to deploy these. And IGMP static filtering defined is something I cover in the next slide that we're going on, and bridge multicast filtering the same. What I do want to mention, this bridge multicast filtering from the first slide is if you ever have multiple master clocks popping up, in other words, you just see multiple master clocks, it is because you're filtering the clock information on the multicast filtering. So there's a function on the Cisco's, the different brands use different things, but it's unregistered, filter unregistered multicast is something that you enable when you're doing video stuff. And that filters out the clock sometimes, and you end up with this weird situation happening. But what I really wanted to show you, and this is now the more detailed stuff, is these are Dante's multicast address. So Dante itself uses these. This is a combination of the audio, the control, the data, and also when you're doing multicast. But what's really important to know is that when you have unregistered multicast filtering enabled, if it filters any of this stuff, Dante starts falling apart really badly, specifically the PTP. PTP is the clock protocol. If that gets filtered, Dante will have clock dropout, that latency thing I pointed out. That's when you're starting to have that issue, is this packet's being screwed with. If you go onto Wireshark, if you know how to use Wireshark, you can actually see sometimes this packet will turn red. That's indicating to you there is a problem with that, and that normally causes clock dropout or any of those sort of things. So it's good to know these addresses. Why this ties into what we just saw is when you set up IGMP static filtering defined, you define these addresses. Now, as I mentioned, Quentin did a Cisco training course last week, and he did explain how this works. If you're dealing with video products like SUSI or Crestron or any of those, they require you to enable unregistered multicast filtering. And as I just highlighted, that will break your Dante system unless you go and ensure these addresses are not being filtered off. Or more specifically, you will open up Dante controller on a port that is being filtered, and you won't see any of the hardware come up. So be very aware of this. These are the multicast addresses that you really want to watch out for from there. And that's my brief out at the end of the session. So we're now at the Q&A section. If you have any questions, I'm really looking forward to answering some. So please fire a few away. We'll give it a few minutes. If no one pops up anything, then we'll skip it from there. But thank you very much for sitting through this. I know this was quite lengthy. I'm really grateful for everybody's time. And obviously, I hope everybody's doing okay during this quarantine thing. It's quite an interesting time.
Hey, Maldwin. So yeah, thanks for doing that. That's really great. Guys have been interacting quite well. There's a question there that says, does the PC running Fire, so just a question about Fire, have to sit on the Dante network, or does it just need to be able to access the Dante network via a VLAN?
That could be interesting mixed up, but it has to sit on the Dante network to a degree. But obviously, if you have a Dante VLAN, that's the same thing, right? Because it's part of the actual Dante network. So it could mean multiple things, but I think to very bluntly answer it, yes, it has to have access to the same Dante network to be able to transmit the audio and send it to other Dante devices from there. But you can get really clever and do VLAN routing using a number of protocols, but that gets into a very complicated method. The other thing I can tell you, though, which is useful, is if you have two Ethernet ports, you can obviously tell Dante Via to only go out to one port, and then the corporate network can be on another port. And on the computer, Dante will only go out the other port. It won't go out the other one. So on some installations where I've had to have a corporate control PC, I've installed a 2-port Ethernet, and there'll be a dedicated port for Dante, and there'll be a dedicated port for the network for internet and corporate stuff, which helps a lot. Maybe something worth mentioning is that standard industry practice is that you don't that you do deploy a dedicated network switch for your AV equipment, separate from a corporate network. But you can deploy Dante on a corporate network. It just requires a lot of those settings that we saw in the last slide to be enabled. The only catch with that as an AV installer is you suddenly need to know a lot about networking, and you create a very big can of worms when you screw with a corporate's network. So you can do it, and DDM is one of those things that helps make corporate networks more manageable and calm down IT people around how you're doing things, because it's got a lot more settings on it, specifically the way that it does distribution of audio across the network.
Thanks, Melvin. Another question was about the Cisco webinar, if that's going to be available to watch. Again, we've just posted the link in the Q&A section to our YouTube channel. If you guys go and subscribe to the channel and click on the bell to get all notifications, as we load them up, you guys will get the notifications. And yeah, we've got the walkthrough, the Harman Pro University walkthrough video on there at the moment. The Cisco one will be going up. The one from this morning will also be going up, and now the Dante one will go up eventually as well, as they get edited and uploaded. So keep an eye on our YouTube channel for that.
We sound like podcasters now, but definitely you guys will be able to access this video. So if some of your colleagues didn't see it, will be uploaded on YouTube. They're more than welcome, and I'm sure some of us will be using this as a reference to just bounce back and see what we saw and use it when we actually get back onto sites again. So from my side, thank you so much, guys. I'm really looking forward to seeing everybody again. I'm tired of seeing my girlfriend every day, and I hope you guys have a good time in lockdown. Cheers.